welcome to this module. In the last module what we discussed is interdigital electrodes for drug screening, right. So, let us understand about SU8. So, SU8 acts as a negative photoresist. So, if we see the photolithography technique, then how we are using photoresist, if you see the screen, photoresist, this we have already discussed, right. Two types, positive, negative. Process flow. So, you take a silicon wafer, first step silicon wafer, second step cleaning, third step photoresist spin coat, next step soft bake, next step mask loading, it can be bright field mask or dark field mask. Next is UV exposure, next one photoresist developer, next hard bake, right. So, this is the photoresist patterning. For positive and negative photoresist. Now, let us see the steps for SU8 which will act as a negative photoresist or which acts as negative photoresist. This we are talking about SU8. In SU8 we will again start with silicon wafer, clean the silicon wafer. So, we say clean and pre-bake to remove any moisture content, clean and pre-bake. Next step SU8 coating using spin coater. Next step is soft bake. Now, in positive and negative photoresist, soft bake is carried out at 90 degree centigrade 1 minute on hot plate. For SU8 soft bake is done at 65 degree centigrade and the time depends on the thickness of SU8. The time of baking depends on the thickness of SU8. After that you perform hard bake. Hard bake is generally done at 90 degree centigrade. Again the time depends on the thickness of SU8. Then we go for UV exposure followed by photoresist developer, and then to harden it we can bake at 125 degree centigrade or above. So, what is the difference? If you see difference between positive and negative photoresist patterning and SU8 patterning. First step is same silicon wafer, second step same clean and pre-bake, third step same photoresist spin coating, fourth step same soft bake, but here soft bake is done at 65 degree centigrade and in positive negative photoresist at 90 degree centigrade. This is for 1 minute on hot plate. In this case SU8 photoresist, the soft bake temperature is 65 degree centigrade, but the time depends on the thickness of SU8 material. Next step in the positive and photoresist is loading of mask, right, but here after soft bake the next step is hard bake. So, in SU8 after soft bake next step is hard bake, but in positive and negative photoresist after soft bake you have to load the mask. After mask there is an exposure. here after soft bake, hard bake there is exposure, after exposure in positive negative photoresist there is a PR developer, and finally there is a hard bake. In this case after soft bake, hard bake, mask loading, UV exposure there is a photoresist developer, and finally you have to bake at 125 degrees centigrade. All right. So, if you have an interdigitated electrodes inside SU8 well. So, this one is my SU8 well, the one with pattern interdigitated electrodes, and let us say this is glass substrate, right. So, in the last module we have seen how to fabricate interdigitated electrodes. In this module let us see how to fabricate SU8 well. So, these are interdigitated electrodes, glass, on this we will spin coat SU8. So, now this is SU8, these are interdigitated electrodes. Okay. Next step is soft bake 65 degrees centigrade, followed by hard bake 90 degrees centigrade, followed by mask loading, followed by UV exposure, right. So, soft bake, hard bake, mask, UV exposure. When I expose this, if there is a mask here, let me draw it correctly. So, soft bake and hard bake is done. So, we load a mask, all right. So, SU8 is negative photoresist, it will act as a negative photoresist. So, unexposed region would be weaker, right, unexposed region would be weaker. So, what we want? We want unexposed region in this particular fashion. So, unexposed region will be in the mask. This is my dark field mask. Okay. Unexposed region. So, if I expose this with UV light, then the unexposed region, right, would be weaker because SU8 acts as negative photoresist. So, after exposure I will dip this wafer in photoresist developer. If I dip the wafer in photoresist developer, what will I have? I will have glass, interdigitated electrodes, SU8, is it correct? No, SU8 pattern in this particular format, right, because the unexposed region would be weaker. See, this was unexposed region and the contact pads were unexposed region, it is weaker, then that is why it is developed in SU8 developer. After this I will bake this wafer at 125 degree centigrade or above to hardened SU8 material. Now, you have SU8 well integrated with interdigitated electrodes, right. So, this is a sensor that you have, and you can use this sensor for several applications. First application that we discussed is drug screening. Drug screening. For drug screening, what I will do? I will take, let us say there are 3 drugs, okay? 3 drugs. I will take 3 sensors, glass is a substrate, interdigitated electrodes, SU8 well, SU8 well, interdigitated electrodes, now we have 3 drugs. Drugs is antibiotics, okay? 3 drugs. What we will do is, if we have sample from patient 1, let us say we have cells from patient 1, we will load these cells inside this well like this. We load the cells on all 3 wells, 1, 2, 3, and we will load with matrigel. Matrigel, matrigel, matrigel. Matrigel acts as an extracellular matrix. Matrigel acts as extracellular matrix, ECM, all right. So, we have cells plus matrigel, here also cells plus matrigel, cells plus matrigel, all 3 chips we have cells plus matrigel. Now, we will measure the impedance with this, what we will measure? Z impedance, these are contact pads, right. So, we measure impedance. We will have some value of impedance. Let us say for this one, first chip we have Z1, Z11, here we have Z21, here we have Z31. This is impedance of the chip when there is when there are cells with matrigel. Now, what we want to do? We want to test different drugs. So, we will add the drug 1 here, we will have drug 2 in second chip, drug 3 in third chip, right. So, when we load the drug, we will have a different impedance depending on drug is effective or not. If a drug is effective, cells would lyse, right, lysing is dying, it is breaking up, cells would lyse and will have different impedance Z12, Z22, Z32, right, you can say Z or Z depending on how you pronounce it. Now, we have to see which impedance, what is the change from Z12 to Z11. Here we have to see what is the change in impedance value from Z2 to Z21. Here we have to see Z3 to Z31. The chip which shows a maximum change in delta Z, the impedance would decrease, the maximum change in delta Z right, or we can say Z11 minus Z12 depending, alright. This will be negative value, but the point is there is a maximum change in delta Z, the impedance would decrease. This is higher impedance, always Z11 is higher, Z12 is lower. So, we can always write like this, right. When there is a maximum change in impedance, that means the conductivity is increasing, that chip we can consider that the drug is more effective. You understand? If the drug is effective, the cells would lyse and it will improve or increase the conductivity of the chip. So, the chip which shows a maximum change in the conductivity or there is a decrease in impedance, that chip, the drug that we used on that chip is effective for our patient 1. Same thing if you have patient second, the drug 1 may not be effective, drug 2 may be effective. For third patient, drug 3 may be effective, drug 1 and 2 may not be effective, or vice versa, it does not matter. So, now we have a platform which we can study the effect of different drugs and we can screen different drugs. That means, this platform can be used to measure the efficacy of different drugs and to screen different drugs. It is a patient centric platform, as for the given cells from the patient we can know out of 3 drugs which drug is effective by looking at the impedance values. Thus, we have designed a sensor that can help us to understand the efficacy of the given drug. Easy, right? That is how you can design the sensor using SU8 material and interdigitated electrodes or using any metal. It can be chrome gold, it can be platinum and titanium, and you can use the silicon as a substrate or you can use a glass as a substrate, and then remains only about the electronics part. Easy, right. I feel that you all have understood the way of how to use this particular platform for drug screening application. Alright. So, we will stop the finish the module here, and in one of the module I will also talk about antibiotic susceptibility, right, bacterial resistance. So, we will see in detail what are the gold standards, what kind of sensors we can design to understand or to capture these bacteria and understand the effect of antibiotics on those bacteria. Alright. So, I will stop my lecture now and I will see you in the next module. Till then, you take care.